on updating or processing the game, like the AI or memories or handle the other things, right? But again, this is just a general practice for our little game. So our game is very simple. Actually, we don't really need that much power. I mean, in terms of CPU power to process things like to move enemy, to handle collision, to process physics, stuff like that in a real game. So because the game is simple, but it is a general good thing to limit the frame rate. Okay, so some many students really they get back to me and say, hey, we even don't really need to do the sleep or all of those things. Just keep rendering. I think that's fine. We can do that, but uh, as I mentioned earlier, it's good to do so. So why not, right? How to do that? In fact, if you understand the idea, so you can figure it out by yourself. So basically, here's the idea. So we say by looking at this picture. So let's say we want to render 2 frames per second. Let's assume that, right? So let's say we want to limit our rendering speed up to 2 frames per second. So in other words, we say in 1 second, we only render maximum 2 frames, right? And then if we divide 1 second into 2, so you look at the area over here. So we say, okay, so each of these time is for rendering a frame, right? So that's why we say tick per frame, which means 2 frames per second means the maximum time for rendering a frame is 1 second divided by 2, right? Which means within half a second, we can only render 1 frame. Agreed? Is that easy to get, right? So, and what we do, we render a frame. Let's say this is the t, the time axis, right? So after we render a frame represented by the bright white lines over here. So this is the time we spend to render the first frame. And we look at the time we actually spend to render a frame and say, hey, so this is the actual time to render a frame. And we compare it with this, with the time, the maximum time for a frame. And we say like, hey, we still have a lot of time left, right? So and then, okay, we go to sleep. And when we wake up and we say, okay, so here we are around here. And we say, okay, we have passed the maximum time to render a frame. And then we can start rendering the next frame and keep doing that. So that's the whole idea. So by looking at the code, you can see we simply just get the current time. We mark the start time of a frame, so which is here, right? So we mark the start time of a frame right now, and then after we render a frame, we keep checking whether the actual time passed is bigger or greater than the tick per frame time, which is the maximum time for a frame. And if the number is still smaller, so we go to sleep. That's the logic, right? So we get the time passed after rendering a frame, and we see that uh, if the time passed is greater than the maximum time for a frame, now it's time to render a new frame. Otherwise, we just go to sleep completely during that time, right? So over here, after finish a frame, and we are here now, and we say, hey, so it is still smaller. The dt here is still smaller, so we go to sleep the rest of the time. Okay. So that's just the idea of how to limit the maximum frame rate. I'll stop here for you to think about it a little bit. Any questions? Now we're up to 42, which is good. No questions so far. So you're good with the idea of limiting the maximum frame rate. So we have the function get tick count, right? So right now actually the slide is kind of on, so which is we are moving to use the get tick count 64, which means allows us to have a bigger number of tick counts. So one tick is about a millisecond, 1,000th of a millisecond. Okay, nobody say anything. Hopefully you understand. So now back to movement a little bit. So if you look at the code to move the brick from left to right, so you see I'm writing like this, right? So some of you might say, yeah, so why don't we do this? Right? It is much smaller. Sorry, much simpler. And why we need to use a physics formula like this, right? So the answer is very simple. So if you update the position of an object by using a formula not depending on time, so your movement will depend on the rendering on specific computer speed. So look at the whole loop over here, right? So if the loop is running on a very fast computer, right, which means in a certain amount of time, it can run so many times, right? Let's say in 1 second, a normal computer can run as fast as 1,000, right? 1,000 loops, right? So you will see that this variable will be increased by 1,000. But if you bring the same loop onto a faster computer, which can loop 2,000 times per second, then you will see that the brick X value will be updated, will be increased like 2,000 times in a second. In other words, your object will move faster, right? So here's the deal. So we don't want our object to move faster or slower when running on a slower or faster computer, right? So we want the speed of our work to stay the same. If the computer is slower, we feel like the frame rates drop, but we see laggy animation. It's fine, but the speed is still the same. Got it, guy? It's just like you use a camera, right? If your camera is so bad, so you don't have a very good video, that's fine, which is the result on the screen. So you can see things move very laggy. But you don't want your object to move like 100 kilometers per hour on one computer, and on another computer it moves just like a snail, like 10 kilometers per hour only, right? So in other words, we don't want our virtual work to have different speed on different computers. That's the idea. So we need to use the real physics formula, which is, okay, the distance moved is equal to speed multiplied by time. Got it?
Yeah, got it.
Okay, so, and this is actually very important. So all movement must use the real physics formula. There is no, you are not allowed to use something like this. It is wrong, plain wrong. At least in this course. Of course, I know that there are certain tricks in movement in certain even modern games, because they are built specific for each computer, for each console. So they can be tuned or they can be tweaked in a way that does not use the real physics all the time. But trust me, they don't do that quite oftenly, right? So it is just wrong to do so. So everything must stick to physics formula. Okay, so especially if I don't see a movement formula without a dt, you are in trouble. I will kill you. Okay. I try to make fun of it, but I'm serious. So if I see you doing animation or rendering without a dt, you will be in big trouble. Okay. Now I stop here. Any questions so far?
I don't have any, sir.
Okay, good. Wow, I feel great. Should I? Nobody asked anything for the whole semester, and then suddenly you say, "Sir, I gave up. I cannot do my work. It's so hard. Why the course is so hard?" If I teach you anything, everything, and then you don't have any question to ask, I know. Up until this point, everything is still easy. Okay, so that's it for the first slide. Nothing to ask, right? Okay, so now let's move on the next sample, this sample where we started to move things around, not things like, I mean, we move code around so that we will be more organized. So yeah, just like who asked me last time on about a Python code. So he's trying to do multiple objects, right? By uh, by just copying sprites. So I know that is wrong, but it's fine because you are new to this programming world. No, not really programming world, but C++ programming world. So you don't know about resource or sharing pointer or trying to be optimized. It's okay, but it's just plain wrong to do so. And we will try to come up with a little framework to help you, right? So okay, so let's take a look at the next sample, which is the sample code here. Oh, by the way, I have updated quite a bit on on sample number 4 collision. So adding a few more interesting things for you to play with. So keep updating the code, okay? Now let's move to the second one. So the skeleton. What is a skeleton? It's just like, okay, we started to break down the the big code of the everything in the previous example. Everything is in one file only, in the main file. So we don't want to do that. So we will splitting, having a better class design. It is not final yet. It is a very first starting point. So yeah. So nothing really fancy about the first sample, except that we introduce a common abstract class for every object in the game, and started to use it as a foundation for a gaming world, right? So let's take a look at it now. So there are 4 things that you might want to take a look at this one. First of all, we will break down, as I mentioned earlier. So we break down everything in the main code into different files. Over here, we have only actually 2 more files. One is the game.cpp, which is the sort of a framework class or utility class. Up to you. It is just for to hide the commonly used functions as a framework for you to use without being worried about how it is implemented. So the game object is actually very simple, just an abstract class for every object in the game. So that's what we are heading to. And the C game object, C game class is a singleton, which is a design pattern. I know that many of you have been using it for a while, but some of you may not know about the concept. It is very simple. Okay, let's take a look at the game class we have here. Nothing really fancy. So if you already look at the first example, so we will move most of the DirectX related variable or global variables into this class. So and hide it, right? So for example, we have the handle to the window. We have the back buffer width and height. Remember it last time. So what is a back buffer, right? A special area of memory inside the GPU, inside the graphic card, so that if we write it, we need to fill up the whole back buffer, and then after that we swap it to the front buffer for the whole frame to be rendered, to be shown on the display, right? We use the back buffer to avoid screen flickering when the drawing process is being taken place by our program. So yeah, and notice anything familiar here? So we have the global object, like for the device object, for the swap chain, which is the whole pointer to the back buffer, to all of the buffers. So we have the rendering target view object, which is the windows where to draw. And we have two new objects, which is the plane state. I will go back to that a little bit, maybe in the next example. And we have the sprite object, which we already created last in the previous example. So actually we only have the plane state alpha here is new. So the sprite object is actually old. And we move quite a few functions from the main file into this class, especially the init function. So the init function, we put it previously we put it on the main CPP file, so we move it here, so that we can reuse it for different games. So the whole idea is to be organized so that we can come up with some sort of a simple game engine, so that you can use it to develop different games, not just Mario, right? So that was why we want the C game class to be game independent. So it does not have game logic inside it. It's just a bunch of things to support you draw, to support you do generic things that most games need. Okay, so it does not have the game logic. So and then we have a draw function, which is just a wrapper function of DirectX 10 to draw something on the screen, to draw a sprite on the screen. But those functions will be replaced, will become obsolete in the next example, because it is very inefficient to use it directly. So I'll explain later when we come to the next sample. And we have a utility function to load a texture, to load a file, an image file from disk onto memory and make it a texture. So you remember in the first example, so there are so many steps need to be taken to load a file into a texture, right? So we simplify everything by just calling this function, and we return a pointer to a special object, which is a pointer to a texture, right? So at this point of time, so this is just a wrapper of the DirectX texture structure, right? Okay. So we have a wrapper of a texture class. So actually, it just wraps around the texture 2D from DirectX 10, right? So that you don't really care about the detail of DirectX 10. Just know it is a texture, very simple. A texture is just an image with a width and a height, and we will hide everything like the resource view, all of those, underlying stuff. So we will hide it for you. I will hide it for you. So you just get a pointer to a texture object. So here, so it is just simple. It is just a structure. So the class texture is nothing more than just a wrapper, so a struct. So there is no real logic into it except the initialize code to and then the destructor to release the underlying texture. So just a wrapper. Okay. So where we are at the game object, right? So that is the load texture function, and all of these function is very straightforward, right? Just allows the outside program, outside code to get access to all of the DirectX related code. So mostly for the rendering function. So and to get the back buffer. So that's it. And we have a special member here, which is a static member, the instance to the to an object, to the class. So this is the singleton design pattern. So it is not, this is not the very very typical implementation of singleton design pattern, just a part of it, right? So if you want to have a class which is strictly a singleton, you need to do more than this, but there is just enough to illustrate the point of a class being a singleton. Actually, there is a template for you to make a class to become a singleton, but it is kind of complex. So, but I'll try to do it simpler over here. So to make a class to become a singleton, what is a singleton class? The singleton class is a class that has only one object all the time. Only one object. There is no more than one object. So how can we make sure that it happens? So over here, if you fully implement it, if you fully implement singleton design pattern, you can enforce that. But over here, we still can pass that rule. But if we do it correctly, we don't have that problem. So we just declare a pointer to the only object of the class here named instance, right? And the function and every singleton class has a static member named getInstance, right? So we don't, so the outside code will not create a class directly. So there is no new, there is no new operation is allowed. So the other class, if it wants to get a pointer to an object of this class, so it has to call the getInstance static member, right? So the instance getInstance static member does something very simple. So it checks if if it has created that object or not. So if it already created, so it just return the pointer. If it is not, so it will create a new object and then return the pointer to that object. So that's it. That's all about being a singleton class, right? And if we look at the main code over here, you look at the render, so you can see that in order to get a pointer to the game object, so I call static function getInstance, right? So I don't care whether the object exists or not. The getInstance function will handle the job for us. Okay, so that is the that's all about the game object. So can you guys take a look at the object and see if you have anything that you don't understand about this object? Is it straightforward for you? Oh, actually, I need to go into the draw function over here. So the code here is quite similar to the code that you saw on the first example, right? So we just add another feature of it. So instead of drawing the whole picture, right? So we allow the code to draw portion of the picture like this. So this is just the only different part. So as you can see, to draw a texture, so the function has 4 parameters, right? So the position you want to draw the texture onto, right? And the texture or the image to be drawn on the screen. And if you specify the pointer to a rectangle object, so which is a portion of the, instead of drawing the whole picture onto the screen, you can select a portion of a picture to draw on the screen by sending a pointer to the rect object here, right? So that's why we check if the rect pointer is null, so we draw the whole thing, which is similar to the code in the first example. But if the rect is not null, so we will pass in the information to for DirectX to know which part of the texture to draw. So there is a little bit of conversion over here into the texture coordinate system. I explain it later. And that's it. And after that, so everything is normal. So we set up the modulate color. I'll go back to that later. So we set up the translation matrix and the scaling matrix to specify the drawing position and everything, and just create a and combine them all and send them to the draw sprite immediate, just like the previous example. Okay, I'll back to the to another window. I'll share another window to explain how to draw. What does it mean to draw a portion of an image, right? So mostly the code over here, why everything is like this, right? So again, if we want to draw the whole picture, so we just set the these parameters just like this, 0, 0, and 1, and 1, and you will understand why it is 0 and why it is 10, right? Sorry, not 10, 1, sorry, 0 and 1 over here. And if you want to draw a portion of it, so the we need to do some calculation over here, and what kind of calculation it is. So I'll show you another. I explain on the slide. So do you see the new slide window?
Yeah, we see that.
Okay. To draw a portion of a sprite, right? So which means, okay, so the whole big picture is what we call a texture, right? So we want to draw a portion of it. For example, we just want to get to draw this little Mario over here, right? So we want to draw it onto the screen. So and then we want to draw, and then how do we specify the this little rectangle within the big texture? So usually you just know like, hey, so where is the location of this little top left corner, right? So and then we want to know the position of this little right and bottom corners, and that is enough. Agree? So, but unfortunately, we can only do that in DirectX 9. So in DirectX 10, things are a little bit more complicated because they wanted to use the texture space coordinate, not the normal image coordinate. So what is the texture space coordinate? Okay, let's look at this picture. Let's assume that this picture width is 367. That is not correct, but let's assume that the width of the of this picture, the big picture, is 367 pixels, right? And we want to tell DirectX to capture, to get to pick a rectangle, to draw a rectangle here, right? So the first step is to specify the top left corner. But the top left corner, so the X position of it is 145, right? So but the rendering engine does not use the width and height as in the integer value like 0 to 367. So it used the texture space, which is from 0 to 1. So 0 to 1. So no matter how big your image is, no matter how small your image is, it is still from 0 to 1. Got it? 0 to 1. So and then how can we calculate the position of this for example, the left, right? Let's say the left of this pixel is in the normal dimension is 145. So how do we know what is the value when translated into the texture coordinate, which means from 0 to 1? How do we know? How do we know the left? Are you still with me?
Yes, we're still with you.
Okay, so how do we calculate it? So simple, right? So just apply the normal. So we divide, we get the number, which is the position in the normal dimension, in the normal pixel dimension, and we divide it by the width, right? And we will come up with a location of this point in the 0 and 1 dimension, right? So this is on the x, similar for the y. So the same, on the y axis, so it is still from 0 to 1, right? So if we want to know the y position of this little corner, so we do the same. So we just get the position of the top value in a normal image dimension and divide it by the width. So we will come up with the number in the 0 to 1 space, right? So that was why we have this part, this little code over here. So you say the texture coordinate x, so we get the left, we divide it by the width here, and y we divide it by the height.
Excuse me, teacher, we can't see your screen. We still see the PowerPoint thing.
The slide, right?
Yes.
Yeah, okay. Okay, nothing really. Let me swap to. Oh, where is that little code? Okay, so. Yep, see the screen now. So that was why you can see that I get the x, right? The left, which means the x value of the top left corner, and divided to the width of the texture or the width of the image. Similar, y we get the top, we divide to the height of the image. So you know why I put a float here, right? Anybody? Why I put a float here? Why I have to treat the width as a float?
Because it's about 0 to 1, so we have to put float here.
If we don't force it to be a float, what happens?
It will come to 0.
Yeah, that's right. Because C will treat this dividend, this operator as an integer divide, right? So which means 0, because left is always smaller than width, so it will become 0. So and so the side x and side y is just the width and length of the rectangle in the texture space. So similar to the same logic. So we want to specify the length of this rectangle, but in the space of 0 and 1. So we just get the length in the normal image dimension, right? And then we just divide it by the length of the texture. So nothing really. Okay. So hopefully you understand why we want to do so. Got it, guys, over here. And some of you may ask, sir, so how do we know the value? So the rectangle. So let's say you want to draw this little area from texture. So how do we know it is at 145, right? So how do we know that? I know that many of you know that already, but for those who don't know, so here is the trick you can do. You can use a lot of other tools, but I prefer using just a simple tool. So with the tool, the name of the tool is pen, right? So I'll open it. Let's say I'll go get the so I will open it using a pen tool here, right? And then I zoom, right? So let's say we want to get this guy, right? So we have to use a selection tool, right? And then we point over here. So do you see the area down here? The area here. It shows you the where are we on the image. Do you see it moving, right? So let's say this position is 276. The x value is 276 and the y value is 154. Do you see what I mean?
Yes, you can see.
Yeah, so we can draw it, and you know the top left coordinate, and you have the side already, right? So you see the side here, the side of the selection here. Okay, and the total dimension of the image is this one. Okay, so that's what I did. Of course, there are much better tools out there on the internet. You can use that. I'm more than welcome to for you to use those tools. I don't care as long as you have the coordinate. Okay. Okay, so that is all about drawing a part of a sprite onto the screen. So you have any questions so far? No?
Hello, teacher. I
uh,
have a small question.
Shoot. I mean,
Uh,
shoot is a usual term in English. Say, hey, just saying it. Okay, shoot. Shoot it. Okay, sorry. Go ahead.
yes, I want to add about the width of right. Why we don't need to add one to the width or height? You can help me
You
come
mean
back to your code. Yeah.
you mean here, this one?
Yeah.
Why is there +1 and why you ask there is a +1, right?
Yeah.
Oh, it is actually a simple trick. So let's say, let me use another slide to demonstrate it. I don't have. Okay, let's say you see the slide, right? So let's assume that one small square is 1 pixel, right? So and then let me say, so if this pixel here is at position 10, right? So the next one will be at the position 11, right? Oops. Right? Right?
Yes.
So how many pixels from here to here? 2 pixels, right? So at the first pixel is 10, the second pixel is 11. So we have to get the right one. We minus to the first one, which is 11 minus to 10 equal 1. But the length is 2, so we need the +1. Got it?
All right, I got it.
Okay, so same. So if it is if this pixel here is at position 12, right? So there are 3 pixels. The length is 3 pixels, and we get 11. Sorry, 12. We minus 2, right? But the pixel we have to +1. So same logic. Got it, guy? Okay.
Thank you.
Great. Yeah. Great. Okay, now let's take a look at the game object. right? This is just a very super simple game object for this example. So we will gradually improve or add new stuff onto the game object. So which is an abstract object for everything in the game. Every object in the game, whether it is an enemy, whether it is our own Mario, a player character, or whether it is just a hidden portal in the game, so that for us to jumping from one scene to another scene. So anything can be a game object, right? So at the very core, every object must have the position in the game world, right? So that was why we have X and Y. So some of you may say, hey, most objects can add Vx, velocity Vx and Vy, or maybe some acceleration like Ax and Ay, stuff like that. I say, well, it's up to us to add many properties as possible, right? But maybe there are some objects which is just don't move, like just like a brick in Mario, so it stays there, right? There are certain bricks that just stay there, so it doesn't have any speed. There's no velocity, so why we have to add Vx and Vy over the core object. So as I imagine, so all of the object must have a position in our gaming world. Otherwise, what is the purpose of an object having no position in our gaming world, which is something else, right? So that is why we have Vx and that's why we have the position of the object in our virtual world. And for now, to simplify things a little bit, so I will store a pointer to the whole texture, to the whole image of the object, so that we can draw it on the screen. So right now we assume that we don't know how to draw portion of a texture onto the screen. We only know that we can draw the whole texture onto the screen. And up until this point, we assume that our work only has object which consists of a whole picture, not just a portion of a picture or a sprite. So so that we store a pointer to a texture. So this will be improved later, right? So and I think those method is very straightforward, just the constructor and get set function, nothing to tell about it, right? And the constructor to initialize the position, right? And we have two virtual functions to update the object and to render the object, right? And we will implement the update function and the render function for the real object, for the specific object. For example, we have two objects in this example: a static brick, right, and Mario. Right? So Mario has a little bit different than the brick because it can move on the screen. So that was why we add two more property like velocity x or Vx and Vy on the screen. Into the object. And if we look at the and again, this is not a good programming practice, right? So we have two classes on the same file, right? So which is not good. So you guys need to break it out. And to implement the game object is pretty simple, right? So we have the normal game object, the generic game object has nothing to do with nothing special. So when we draw, we just draw the whole texture, okay? And when we finish, so we can delete the texture. Right? And for Mario, so to update Mario, so we use we allow Mario to bouncing back and forth, just like in the previous example. Nothing really fancy about this logic, just moving back and forth the screen. And that's pretty much it on the main file. So you can see that I create a Mario, a texture for Mario. I have a pointer to a texture of the brick and a texture of all the object, right? And over here I have a pointer to Mario object, one object, which is Mario, and one object of type brick, right? So we have one brick and one Mario. And you can see in when we load a resource, so we use a function load texture, right? So we provide the texture part over here, and then we load it onto
Sir,
the.
can I ask you a
Yes.
question? Excuse me. What is the text mixed?
Oh, it's just a generic image of a lot more thing. Here is the image. You know. So basically, I want to draw the question trick. That's why it is the texture. Got it?
Oh, okay. Thanks. I got it.
So we have the prick, a normal prick, a texture, and just another texture. So and then I create Mario by specify the position of Mario, right? And the pointer to the texture into the object, and the brick I put it onto the texture brick over here, right? And to update, so right now when calling update a brick, we actually don't do anything because the brick doesn't have any logic. It just stays there, right? So there's no logic. But Mario, because in the example, I want Mario to move from left to right, just like the brick in the previous example. So in the update function of Mario, which we already seen, so we see we update the velocity of Mario. And to render a frame, similar logic. So you can see, so the framework here just the same, right? But the actual part of it is to render a brick and render Mario. And over here we try the function to render portion of a text, right? So it is actually not an object, but it is just to draw something on the screen, right? To draw portion of a text onto a screen. To try the new draw function that I explained earlier. Okay, so let's comment out this line, not to and run it. So you can see that we have a yellow brick over here and Mario moving from left to right. Okay. Now I'll stop here and let you guys to try it at your side. And also please notify that. Please notice that you see the way I use the window title to show the current Mario position. Do you see this one? It's keep updating, right? So which is this is a very simple but good way to debug your program, right? So because we have everything is running into a loop, so it's sometimes very hard to do the breakpoint or to look at the debug log because everything brings so fast. Sometimes it is better to put it onto a little window title here to see how things changing, so that you can notice something strange on your object, right? So make sure that you use those capacity in your debug session. So the function to do that is the function named debug out title, right? So you just draw a string onto the title using this function. Okay, so I stop here. Let you guys try the example by yourself, and then please build an exercise. Please do an exercise to if I want to have like a line of bricks or down here instead of just one brick, what should you do to change that? Okay, I want to have many bricks object. Do you guys still following me? You understand what I'm asking?
Yeah.
So instead of just one brick down here, yeah, I want you to create so many bricks. But before you do that, so we have many bricks, right? Do we need to load? For example, you want to create 10 bricks. Do you think that you will need to load 10 times the texture, the brick texture object here? For example, over here I have a resource, right? So the texture brick. So if you want to create like 10 brick object, so should we run this load texture function 10 times?
No.
Should we? If we want to create like 10 more console load 10
I think
texture, 10 brick texture.
it doesn't it isn't necessary because this is I don't know why, but I think it don't need to you don't need to create more text brick right there.
Yeah,
because
you were right. So we don't need to. Yeah. Because why? Why? Just
I think it's a loading text function, so we don't
tell
need
me
to.
your opinion. I don't care if it is wrong or not.
What?
Okay, so here's the deal. So all of the bricks use the same image, right? So you only need one image in the memory, and then you can use the same image to draw it 10 times on the screen, right? So you don't really need 10 copies of the image on memory to draw it on the screen. So that is wasteful of memory. Got it, guys? Of course, you can load it 10 times, but it is wasteful, not necessary, and makes your game occupy more memory than actually needed. Right? So let's assume that we have a very big game world where we have a million bricks object. So does that mean we have to load? Does that mean we have to have like a million copies of the same picture on the memory? No, we don't. Right? We only need just one copy of the pictures in memory, and we can use that same image to draw onto the screen many times. So that was why even if we have multiple bricks object here, we still only need one load it once. Hello, still with me?
Yes, sir.
Okay, so now let's spend time trying to do that little exercise right now and see what happened. So to be honest, I'm actually put some hint over the source code for you all down here already. Try to use that, okay? Okay, I will stop sharing the screen and then give you about 5 to 10 minutes to actually compile and try this example and build a okay. So I'll be back and see, and some of you might show me how to do it. Okay. Hello, where are we? Anybody finished the job? Can you show me how to do the task? So right now we have 39 only. So some of you have dropped the call. Hello? Anybody is there?
We are here.
Okay,
We
still figuring it out.
Yeah.
Okay. Look at my my little hint, right?
Teachers, I have done it. Can I share my screen?
Sure. Do it.
Okay. Did you see it?
Good. Looks good. So what did you do to
Okay. Yeah. Can you see the code? Okay. First, I create an array of brick. And I decided the number of brick by the screen width divide the width.
Okay.
So
With.
okay, next in the load result function, I just have to run a for loop to create the um, the bricks,
And
I do the same in the update function.
okay.
And
About
when
inside the load resource? Yeah.
okay, that's all.
Now, what about the load resource function? So how do you load? How you create the brick? So oh yeah, load resource. Oh, you were there. Yeah. So you load it over here. Assign it to the array of brick. Good. Okay. Yep. You know, so the modern C library, they have quite a few data structure that support, that allows us to that is better than using standard array. So there is in my example, if you look at the comment section, so do you see that I have a vector using a vector template class? Do you see it here? Let me share you my screen again. Oh, actually you can use it. Hey, stop.
Okay.
Yeah. So you can use scroll up. Can you scroll up to the top, almost to the top? Yeah, and go down a little bit, down a little bit. Yep. So you see, yeah, there is a vector template class. So basically, it is similar to an array, but much more powerful in terms of you can add, you can delete, and you can delete it, and it is dynamically allocated for you. So you don't have to using the new operator like that. So but it's up to you whether you want to use a standard class or a standard template class, or you use just normal array. Okay.
Yes. Okay. So I
Great.
stop.
Thank you.
Okay.
But you are doing good. So that's the right way to do. Okay. Anybody else could finish and do the same. I'll wait for another few minutes, like up to 3 p.m. so that we at least finish the exercise. Hey, in the meantime, Hill, if you have time, so why don't you try to create another object, like inside of a static brick. So can you create another moving object like a Goomba or something?
Moving, does it have animation or just moving?
No, not just the just one image, but just moving, but using just one frame static, just like Mario. We will learn about animation next. Don't worry about that. So yeah, create another object named Goomba and try to make Goomba moving on a different pattern on the screen, right?
Okay.
While waiting for others to finish. Hello, are we done? Anybody else? Show me your result. Anybody? No, not at all. Is it too hard? Any problem that I can help you with? Hello? Hello, knock knock. Anybody there?
Okay, I have a bug here, bro, teacher.
Yeah, sure. Show me your screen.
I know this bug
Hopefully I can
is
help you.
a little stupid, but I don't know how to debug it. Yeah, I have.
Don't worry.
Arrow
No.
here,
Stupid or bug is
and I don't know how to debug it.
I don't really see it. Anyway, I can see it. It's kind of small. The term pack is not required. The name of it. What? The one that you highlight. Oh, actually, I already fixed that one for you. So yeah. Can you go to the debug.h file?
Okay, here.
Yeah. Just put in the constant argument instead of just put in the constant. Yes. Same function up and top.
Like that?
No. So there is a debug out function just above this function.
Here.
Yeah, that one. Add the constant.
And with a cost. Okay.
No. Both of them need the constant. Both of them. Yeah.
Okay.
So that is my. Okay, can you try it again? See if it works.
Okay, where's okay? Do we need to fix everywhere else, teacher?
So you had to fix the error, right?
Yeah.
Oh, I mean the now go back to the debug.cpp, do the same. So right, yeah.
Okay, hopefully
Okay.
it will run.
Oh.
Thanks. Thank you very much, teacher.
You're welcome. My job. Okay, now go back and do the exercise. Anybody else have any problem?
I try to use your solution by using vector, but I got problems here. Can you watch it?
Yes.
Let me show you the screen.
Mm-hmm.
Okay, here you see that. Here I initiate bricks vector. There, then I try to load in resource from here. I try your tips. So
Hint.
here I try to use your hint, so I stuck here. I don't know why.
Oh, because the constant here somehow not yet declared yet. So you go up to see if we missed anything. The prick width somehow it's lost, right? So just go over define it. Did I put it somewhere else? It's supposed to be there. Oh, actually, I forgot to put that in. Yeah, but you can put that in. It's supposed to be 16, right? Prick width. So 16, I believe so. 16.
F?
Mhm.
Oh no.
No.
16.
Mhm.
Okay.
Same, 16.
Right. Okay. Let's move on this render.
So you just loop it, right? So there is a hint on how
After
to.
so after I update it, I must render it, right?
Mhm.
Let me try it.
Okay, I think you are good to go.
Okay, let's try it. No. Okay, let me try. Let me fix it. Yeah. Thanks.
Okay, 3 more minutes only. Okay, so we need to move on with the next example. So the next example is actually very complicated. We don't have anything new in terms of DirectX to learn almost from here. So, but the framework is a bit of complicated. So we need to focus, right? So 3 more minutes, guys, and go back to the lesson. Okay. Okay, so let's move to the next lesson. Okay, do you see my screen over here, right? So the next thing that we need to do animation is to prepare for transparent sprite. So with our transparent sprite, so we will see just rectangle around the around Mario. For example, if we don't make Mario transparent, we will see something just like on just like that, right? So we will see the white pixels around Mario. So how to make the pixel? surround material to become transparent. So that is the topic of how to make a transparent sprite. So in order to do the transparent sprite, we have to do 2 steps. First of all is to enable alpha blending. So that is the alpha blending function from DirectX, and then we need to do a manual task to convert the color we want to make transparent in the sprite to become transparent, right? So that part we will have to use an external software like GIMP, right? So let's explain a bit about what is alpha blending, right? You don't really need to understand this part because the code is there, so you may just want to use it. But if you want to understand a little bit on how the graphics, the 3D graphic works, so you may want to look at that and understand it from like 100 miles above. So okay, now let's go into the alpha blending concept, right? So what is color blending? So basically, color blending is all about, so you have 2 images, right? So you want to combine them together to produce into another image. So you did that all the time, or you saw people do that all the time by using Photoshop or image editing software like Photoshop, GIMP, or even some simple image editor on the phone right these days. So we have an image, we have another one, so we want to put the other image on top of the existing image or blend them together to make one transparent, look like looking through a glass or something like that. So, but at the heart of most operation is the color blending operation. So thinking of an image is complicated, but if you break down an image into individual pixels, so the task will be very simple. So you have 2 pixels, right? And then you want to combine them into a new pixel. So what should we do, right? So that is the color blending in general. So the color blending is just a formula, a mathematic formula, like this, like the one we are seeing here. So the source color is a pixel color, right? And the destination colors is the color of the other pixel, right? And then we apply this formula to produce the final another pixel. So that is all color blending is about, to combine 2 pixels into another pixel. It's form, right? Before we go into explain the formula a little bit more, so let's look at the pixel format. So we all know that a colors or pixel on the screen in the RGB color space consists of 3 elements, like the red channel on the red color, the green color, and the blue colors. But these days, in this day hardware, so we have another channel called alpha. Alpha is, as I said over here, is to specify how transparent that is, right? So a value of one here means like completely white. Is the default value, which means that pixel is completely opaque, which means you cannot see through it. But if the pixel, that value is 0, if that channel is 0, so that pixel is completely transparent, which means don't display it on the screen, right? And in DirectX 10, so it does not use the integer value. So right, if you still remember, so each in a normal RGB format, so each component is a value of an integer value from 1 to 255, right? Which means like 8 bits, right? That is the usual format, as I say it over here, down here. So R8, G8, BA, and A8, which means each channel consists of 8 bits. So, but those are just this is just the most popular format, but there are many pixel format in the real life. So it might be hard to use different values. So DirectX will standardize everything into 0 to 1 space, so which is they call the color space. So standardized color space to 1 to 0. So 0, the original 0 means 0, and 255 here will mean 1, right? So does that sound familiar to you right now? Similar to what we have in the texture space here. So mapping everything into 0 and 1 will be very convenient for mathematical operation. So that was why everything will be converted into the standard space of 0 and 1. Okay, so we have the alpha channel over here. So, and remember, each pixel has an alpha value, right? So now let's get back to the blending operation. So look at the formula here. So we have a pixel, the source pixel, and then we have the adjustment factor, right? And then we have the operation like plus, minus, or multiply, and we have the another pixel, and we have the modification for the other pixel. So and then we combine together using this formula, right? And we can apply different settings for different for these three stuff, like for the source factor or the operation or the destination factor. We can choose a lot in a lot of options over there, right? So alpha blending is just a special case of this formula, where the source factor is actually the alpha of the source of one pixel, of that pixel, and the destination and the destination factor is using the this value. We get the alpha value from the source color and invert it. Invert it means we get 1 to we minus source alpha, right? And then the operation here is a plus. For example, if we look at the let's say if the pixel if the pixel has an alpha value of 0.7, and then the formula will become like source color multiplied by 0.5 and destination color multiplied by 0.3, right? Or it means that the final color is made up of 70% of the source pixel and 30% of the destination color. So, and that means two pixels are somewhat blending to each other, right? In a way. And the overall result is that we seem like two images are blending together. So that is called the alpha blending. And the code to set up is very straightforward. Over here, when we initiate the engine at the end, so we create the formula right here. Right, so this is just to create the formula, to create an alpha blending formula, so that before we render, so we apply the created formula onto the rendering. So you can see something very familiar, right? So source blending, so we can see the blend the source alpha, right? And the destination blending is the invert source alpha, and the blend operation is using add, right? So let's go back to the slide here, right? Source alpha. So this one is called invert source alpha, and the operation is plus, right? So that we can see over here. So we don't need to worry about these three parameters. So after we set it up, so we have the blending formula set up, and before we go into rendering, we just apply it here. So before we start rendering anything, so we apply the formula that we created previously, right? And that is all about alpha blending. Okay, still with me? I would want to say, like, if you don't understand, it's fine, because you just use it. So I'm not that I don't really need you to understand that. If you're curious, it's good. If don't, no matter. Don't worry about that. So let's go into how to make a color become transparent. So you need to use a special software. Any software is fine, but I get used to use GIMP or GIMP. Right? Do you see it on my screen? Here is the software. So it is an open source. Not very good compared to Photoshop, but yeah, just simple enough to do the job, right? On how to make a color to become transparent, right? Transparent means we create an alpha channel to mark that pixel to be transparent, so that when we apply the alpha blending formula onto the image, so that pixel will become 0. Okay. But before we go into that, if you look at the formula again, so if the source alpha is 0, right? So you can see that the the color multiplied by 0 is 0, right? And the final color is the destination color. So the destination color is the color that already exists. So the source color is the color that we want to start it to write onto the existing pixel. So yeah, maybe I'm going too far onto the alpha blending stuff, but I'll show you how to do it using GIMP. Okay, so we have the we open GIMP, and then we open a picture. Let's say we want to convert the this texture onto a transparent, to make it transparent. What is going on? Did I miss something? Oh, so we want to make this little colors, right, to become transparent, right? How can we do that? So we use the color to alpha, right? Right, and then after that we use the picker here. So we just select the color we want to make it transparent, right? And we need to modify this value to 0. So spend your time reading GIMP help so that you can see that everything will become transparent. Okay, guys, do you see it? And after you do that, you will see the guy become transparent. Okay, so I'll demonstrate it on the on Mario. Okay, so let's say I stop doing that here. So I will move on to the next. Things seem to be very slow. So do you see that Mario is drawing correctly, right? So, but if I switch to the non-transparent version of the texture or the image, we will have problem. Let me close on the tab. Here, so if I switch to the normal Mario, for some reason my computer has become very slow. So do you see that without using using the function to convert the color to alpha, so we won't have the transparent sprite. Okay, I'll stop here a little bit for you to ask a question if any. So 2 steps, remember, turn on alpha blending, and the second step is to actually use a Photoshop, or GIMP in this case, to convert the background pixel into a transparent pixel using the color to alpha features of GIMP, as I demonstrated earlier. Are we good? Are we good to go? Guys? No question? Everything's clear? So you have GIMP installed it already, right? Okay, so if you don't have any questions, so let's move on to the sample 2. Sorry, the sample, yeah, is it the sample number 2? Yes, the sample number 2 on how do we create a framework supporting animation, right? So we don't have any new function at all, but we just rearrange them into a different classes so that we can do animation and bind it onto the object easier, right? So how do we define an animation? So if you look at an animation, so it is very simple to the whole frame animation, but it's just an animation for individual object. So how do we create an illusion of Mario's walking, right? So we know how to move object on the screen by just changing its position, right? So now we will add one more trick. So when changing position, we change the sprite image as well to create the illusion that Mario is actually walking. So if we scroll through this slide very quickly, right? You have an illusion that Mario is moving. That is the trick. So in order to do that, it's pretty simple. So we have Mario object, right? The same Mario object. We keep moving it from left to right, but after a while, we change the image to render into this image, and after a certain amount of time, so we switch to another image, right? And keep doing that, right? So that is what we call an animation. So an object has many animations attached to it. So for example, for Mario, we have walking is one animation. So even walking from left to right is one animation. And we have another animation is to walking from right to left, and another animation to just stand still, right? And we have jumping animation. So when Mario jump, the image we draw on the screen. So an object might have animations attached to it. So usually one state of the object, we need an associate animation with it. So Mario walking, we need an animation associated with it. Mario running, maybe we need a different set of animation for it, right? So animation here is the core object. So and what it is. Okay, so what is an animation? So if you look at my example, we can see an animation is nothing more than a list of frames, right? And we display the frame in a specific order to create the illusion of moving. For example, the walking animation consists of 3 frames, and that's frame 1, frame 2, and frame 3 again, right? So and then what is so and then by the programming definition, an animation is nothing more than an array of frames, right? So and then we keep render frame 1, frame 2, frame 3, frame, that depends on how complex animation it is, usually per animation. But what is a frame, right? So a frame in Mario example, it's just a sprite, right? What is a sprite anyway? A sprite is a small portion of a texture, like we explored earlier over here, right? A portion of a texture is called a sprite. Right? And so an animation is an array of frames, and a frame consists of a sprite and usually a time value, because we want to specify how fast it is we want to display the animation, right? So that is the time to display the frame before we move on to another frame. If the time is up, so we move into render another frame. Are you still with me here? Hello, somebody is on camera with background noise. I think Huy. Are you? Yeah. Are you guys still with me up until now? So, and a
Yes, sir.
sprite is just a function of an image, right? And an image is just a texture. So, but we need to create classes for all of these little definition. That's what the whole example is all about. So we all know that in the previous example we create a wrapper class to wrap around the direct 3D 10 texture object, right? And now we will have a management class textures to store all of the texture we load into our game, right? And and we have a sprite objects with a similar function as a texture as a wrapper. So we do have a sprite object in in direct 3D, right? But we don't want to use that structure directly. So we create a class to wrap around a sprite. And similar to texture, so we have a management class to store all of the sprites that we created in our game, right? And based on individual sprites, so we create an animation frame, which is one part of an animation. And then on top of animation frame, we have an animation class to include an array of frames, right? And then similar to sprites and textures, so we have a database of all animations in our game. So let's see those classes in action by looking at the source code, right? So, but let's stop here for a moment. So do you understand the original purpose of all of those new classes here? Anything hard to understand here?
I think if you wanna add any surprise or animation, you have to use the classes. Yeah, and texture, I think.
I don't understand your question. So are you asking that if we want to create a new sprite or a new texture, so we have to use those classes, right?
Yeah.
It's true. In fact, you know what? So this is just an example, a beginning, right? It is not that bad, to be honest, but it is not super great. It is not the best design in the world. So I would say like my hint here, my design here is almost enough for 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 building the whole stuff, right? But if you don't like my design, it's okay. You can come up with your own design, right? Your own classes. Got it? But if you don't think like, hey, but if you don't think like you can do better than me, and then yeah, let's keep using my classes. I think it's enough to build a very complex game.
Okay, so I got it.
Mm-hmm. Okay, now let's take a look at uh, individual classes that we have here. So the texture class. So I think we visit this one already, right? So nothing really stand out about the texture class. So you can see that basically I wrap around the direct 3D 10 texture to the object. That's it. So that's all, right? And of course the resource field so that we can access the texture, but we wrap around and hide the complexity of using a texture, right? And that's it. So nothing special about this one texture. Now let's take a look at the textures management class. So it is my habit to add an S after an object after a class to say that this is the management class. So basically, this is an array of textures. So nothing more than that. So you can see that I'm using a special data structure, an order map. So why don't I use vector, right? So vector is subject. So we have to put the object next to each other. But over here, I don't want that. That is so limited. So I want a texture to be identified by an ID, right? So that was why an order map is just like a dictionary. So, right. So you have a key, right, and you have a value. Oh, actually, this is a bad example. So, but we can use it. So let's say we define. So this is LP texture, huh? So as a dictionary, so each word is a key, and the word definition is the value. So given a key, we can quickly look up and come up with the associated value, right? So an order map serves exactly the same purpose. So over here, we give a texture, each texture an ID, right, an identifier. So and then by and when we provide an identifier, we get just it. So because we have a list of texture, and we say instead of saying this is texture 1, texture 2, texture 3, so I don't want to say, so I want this my texture 10,000, texture 2,000, and texture 3,000. And when I want to get texture 1,000, I can get back my texture very quickly. So using the unordered map is not that important for texture, because for a game we don't have that many textures, to be honest. Our game is very simple, but in a complex game, so we have a lot of file, a lot of image, right? And if we move to sprite object, so there are a lot of sprites around. So we need an ID for each sprite so that we can refer them back very quickly. So that's why we use an order map. So an order map is easy to use. It is used like similar, very similar to a normal array, right? It's just that the key doesn't have to be next to each other, right? Instead of 0, 1, 2, 3, 4, 5, 6 up into a specific number, like an array. But with 1,000, 5,000, 16,000, a million, the key can be any integer value. So it doesn't have to be next to each other, right? So that was why I use an order map. Right, and pretty much it. So so you see something familiar over here. We have a singleton, right? So with the get instant, because we don't want to have so many object of textures class over here, right? One game, one object to manage all the texture of the game is enough, and that's it. So and then we have a function to wrap around the unordered map structure over here. We have a function to add a texture into the database by providing an ID, right? And the pointer to the path, and a function to retrieve the texture pointer when provide an ID, right? So let's take a look at the so super simple. So when we add a texture onto the database, we simply load the texture, right? Using the load texture utility function in the cgame class, and then we assign it a key, and we assign it to the to this position, and pretty much it. And then when we get, so we provide the ID, right? And then we just retrieve the texture. Nothing really stands out over here, right? And if you look at the source code, so we use it in the load resource function here. So we get the texture management class, and then we add a texture. So over here we add texture Mario, and over here we add texture of the other objects, right? So, and the definition here is just up to us. So I can use any number I want. So it doesn't have to be 1, 2, 3. So you can see the definition of this one is 0. Haha, and enemy is 10, and miss is 20. That's my way. So you can make it 0, 100, 200, doesn't matter, as long as the IDs are different. Okay. Any questions so far on the texture class? Texture and textures management class? No? Okay. So if you don't have any question, let's move on with the sprite object. So a sprite object, so nothing really stands out neither. So you can see that a sprite is a portion of an image. And that's why we have left top, right bottom, right? Very straightforward. And similar to texture, we have an ID, so that we can quickly get a sprite out of the database by just using the ID instead of, you know, having a pointer to it. And we wrap around, so we store a pointer to the texture that the sprite is in, right? So for example, we want to get a sprite of Mario, and we know that this sprite belonging to Mario texture, right? And of course, because we wrap around a sprite of DirectX 10 sprite, so that's why we have a structure, the real structure over here to render down here. And we also store, because we don't want to have to initiate the scaling matrix every time we draw, because the size of the sprite does not change over time, right? Only its position. So remember, when we want to render a sprite, we have to do 2 steps. We have to specify the translation matrix, and to specify where to draw, and we have to specify the scaling matrix to specify the width and height to draw, right? And multiply them together to come up with a final matrix to draw. But the scaling matrix doesn't change, because the dimension of the sprite doesn't change over time. So that's why we store the scaling matrix over here as well. Okay, and that's it. So that is just a sprite is mostly a structure rather than a real class. But we wrap around the draw function here, so that we can draw a sprite, right? So after we have defined everything for a sprite, so we draw it, right? So to draw a sprite is pretty simple. We don't use the function in the C game class anymore. So we skip most of it, and we just call the draw sprite immediate very quickly, because most of the preparation and setting, we done it here when we first create the sprite already, right? So we move the code over here, and then whenever we want to draw a sprite at position X and Y, so we just fill the translation matrix, right? And then we draw a sprite immediately. Any question here? No. So similar to the texture. Sorry.
Yeah, I got no questions.
Có em.
Go ahead.
Yeah.
I got no questions.
Okay, sorry. Thank you. Hopefully everything is straightforward. So the same. So we will have a class named C Sprites, right, with an S, to manage all of the sprites that we load into our game. So very similar. I don't think I want to say anything about this anymore. So it's 100% similar to textures object. So you go see it by yourself. And over here is how to use the sprite, right? For example, we want to load Mario with 3 sprites here, right? So we just define the ID over here, and then top left right corner of the sprite object, of the the portion of the sprite inside Mario texture, right? Let's take a look again. Mario texture is here. Right. Right, so this guy is around here, right? So we want to Mario. So this guy is at 246, right? 246 is around here. Do you see it down there? 246, right? Just the top left and right bottom corner. So nothing really fancy. So a bit of hard work. So we specify the sprite inside the texture Mario, so that when and then we load it and we save it here. Just add a lot. And over here is the sprite for the for what? For the sorry. Let me run it. So we have another stop. And I remember. And the sprite for the question brick. You see the question brick is over here, right? So and then we load the question brick here. Right, so there are 4 sprites, 1, 2, 3, 4. Right. Okay, the next class is a animation frame. Well, I don't think animation frame is anything fancy. It's just a structure more than a class. So we have the pointer to the sprite to make up the animation to the animation frame. So in most cases, one frame of animation consists of one sprite, right? As in our game, most of the situation is like that. But in some specific cases, there might be a situation where a frame is made up of a several sprites. For example, if you look at this sprite, so do you see the door, right? A door is made up of 2 sprites, right? One on top and one below. So you have to draw 2 sprites in order to make up a door, right? Or if you want to draw something like a platform, so there's a moving platform, right? So you have to combine the beginning part, the middle part, and the ending part in order to make up an object. So there are cases where to render one frame, so you need to render more than one sprite. But it's your job. So I just give you a hint, and you can inherit the animation frame object to define an animation frame consists of more than one sprite. It's your job. But same. So we have the one animation frame, right? Nothing really stand out here, just a structure. And we have animation. So an animation is a list of animation frame, right? Very straightforward. A vector here is an array of animation frame, and we need some value to store to know that when we render an animation, we know what is the current animation, why we have the current frame over here, and we need to store the beginning time of the current animation frame, so that we know that how much time has passed, so that we know when to switch into another frame, right? So the whole thing about animation is the logic on how to switch to another frame, right? So that's why the render function is the most important function. So the whole logic of the rendering function is to identify the current frame. So what is the current frame right now? So we store the current frame, but is it necessary to move the current frame to another frame, right? So the logic is very simple. So if when we first initiate the object, so there is no current frame, so we set the current frame to 0, and we mark that the time we draw the current frame is now, right? Which means the get tick count. So very standard. So and then we measure the time passed. So if the time passed is greater than t, t is the time to stay in one frame, right? So we just get the current frame and we get the time of that frame. So if the time passed is greater than the time we need to stay in the frame, so we advance the frame, right? Nothing really complex here. So and then when we switch to another frame, we mark the time that we switch to a new frame. And if we go into the last frame, so we go back to frame 0, and that's it. So that is how we handle animation. So it's just looping, right? We render frame 1, frame 2, frame 3, frame 4, frame 5, and then go back to 0, 1, 2, 3, 4, and go back. That's it. And the last object is, yeah, very similar to the whole thing, right? To the whole sprite sprite texture. So we store all of the animation in the into the memory, right? So here how to use it, right? So over here you see that we load texture, we load sprite, right? And we create an animation here, and we add sprite to make up an animation. So when the add function will create animation frames underneath, right? And this is the default frame time by 100, so you can change it. Sometimes we want to decrease the animation time. For example, when Mario is running, and if we still use the same animation speed as Mario walking, it doesn't seem very nice. So if we want to make Mario seem to run faster, so we decrease the animation time, that will create the illusion of Mario actually running faster, right? So we create an animation, add frames to it, and then we add the animation, the newly created animation into the animation database, and go on, go on, go on. So, and how to use the animation in Mario, right? So we go into Mario. So nothing about Mario because we still moving him just like the previous example. And just that in render. Yeah, so there are two. So animation is from right. Other animation is moving from right to left, right? So very simple. And to know Mario is moving from left to right is to look at the Vx variable, right? If Vx is greater than 0, which means he's moving from left to right. So because we know that the animation ID 500 is the animation of Mario moving from left to right. That's why we get the pointer to the animation, right? We get that animation out of the animation database, and then we just render the animation, and that's it. So for the brick, similar. The brick doesn't have any complex logic of, well, the brick just have one state, right? Or maybe if you want to, if the brick has more state than we are doing here, we are doing now. For example, if Mario hit the question brick, it will become dead, right? Not really dead in a way, but it becomes like depleted of item, right? So it will become another state. So it depends on the state of the object, so that we know how to select the right animation. But for now, the brick only animation 510 for the brick. So again, this example is not great because I use a lot of hard-coded things over here. So you will see much better shape of the code in the in example number 4. But this is just I want to make it simple for you to quickly get the idea. Okay, I think that's it for today. I know that the framework is, I'm not sure if it is overwhelmed for you, but you should try it. And after you you finish, I would want you to try to use the framework here to load Goomba onto the screen, right? So where is Goomba? Goomba is on the enemy, right? So we have Goomba here. Can you get Goomba on the screen for me? Hello. I think I'm done with
top left one.
lecturing. Right. So yeah, can you modify my code a little bit so that to create any other animation. So instead of using the instead of so right now we have Mario, right? Right now we have Mario moving. Oh, why we have this one? Because we use the non-transparent person, but doesn't matter. So we have a question brick, right? So can you make a Goomba walking left and right over here? Oh no, it's not. It's not the one. A Goomba here. He's on top. Here is his frame. Can you make a Goomba walking left and right as well? Right now. Got it, guys? Do you have any other questions before we stop for waiting for you to do the little exercise? Add Goomba onto the screen and moving and animate it.
By the way, who is Gumba?
Gosh, I just told you.
The
Oh.
turtle.
Oh, the turtle. Okay, I don't hear it clearly because my
Not the
internet
turtle.
connection.
No,
What?
not the turtle. The mushroom. The mushroom.
The
Goomba
mushroom
is the
like?
mushroom.
Okay, sorry
The
about
mushroom here. So
because
the turtle is actually Koopa, right? Koopas.
Okay.
Yeah. Yeah, you know, you can do any of them. I don't care. So as long as you have another object moving and animated on the screen. But if you choose Koopa, you might be in trouble because we don't have the you know, the other side, right? So we only have animation from right to left. We don't have animation from left to right. So what should we do? What should you do?
We flip it.
Flip the texture.
So you have two options. So yes, you can use the DirectX to flip the image on the fly. Yeah, if you know how to do it, great. But yeah, I don't show you how to do it. Just Google it and it will be there very quick, very simple. But if you don't know how to do that, very simple. Use Photoshop to flip the image and have another image and another texture. Okay. Or use Photoshop to actually copy Koopa over here and flip it there. Okay, hello?
Okay.
Actually, we use that way, teacher.
That's right. I don't think it's the bad way at all. Right? So, you know, using the
excuse
most
me.
simple way. What?
Your connection has problem. We see you talking like a robot. You know, like Darth Vader wearing a mask.
I don't hear you at all. What are
Oh.
you talking
I
about?
think you
My
are
background or
having
something?
connection issues.
Yeah, you had the connection
okay.
problem. Yeah.
Oh, okay. But I think it's better now, right? Because I can hear you very well.
Yeah, it's somewhat better.
Yeah, we just see you talking like Darth Vader wearing a mask. It's like a robot, you know.
Okay, like robot voice. Okay, got it. Now do the job, please. I think it's better to do Goomba because Goomba doesn't have left and right animation, right? Left and right animation are the same. But if you do Koopa, so you have to Photoshop a little bit. So copy Koopa from here and flip it over there, right? Okay, I'll leave you guys doing the exercise here. I'll be back in maybe 10, 15 minutes. Hopefully it is enough for you. Okay. Anybody is done? So basically you need to add one more object, name one more class, right? So you can inherit it from the C game object, or maybe you reuse Mario. No, I don't think so. But you can copy from Mario, right? And just move it similar to moving Mario. Oh, by the way, I have create an assignment for you. Now this time just 1 week, right? Now do you see? Can you see my screen? So you need to add a tile background into the second example 02 sprite. So what does that mean? You have to commit onto your repo, right? And then I'll take a look at it. So when you submit the assignment, you just send me the link to your GitHub again. So I'll know that you will be done. Okay. Hello.
Okay, sir.
You understand what is a tile background? I know many of you do, but you can just Google it. Right. So instead of having to store a big image, right? So we break down the image into a tile, right? And then we can compose the big image by just using a tile. But actually, my screen is not showing the correct concept. Yeah. No, not this one. No, not this one. Yeah, but we can look at the Mario. Why the computer is very slow now? Yeah, for example, instead of having to store a big image like this one, right? So this image is just composed of a little tile, right, over here, so that we can use a tile map instead of just using for having to right. I think you can quickly Google it and you get it very quickly. So I don't really need to tell you what to do. So sometimes you have to to learn by yourself a little bit. Any problem with that, guys? Are we good with the tile background concept?
You mean we have to make a background for the games? I mean, just
No, you don't have to.
But
Here,
I mean,
look
just
at the
create just the background, just a type background.
yeah. So you know that Mario, the game, and work 1.1, it has a tile background, right? It has a background. So now in our second example, we don't have a background. It's just a single color background. So I want to fill in the background with an image, but instead of a big image, I want to make a tile image. Get it? No. What about hold on, let me search for the tile image and I show it to you. So do you see my screen over here? So basically we have tile, right? So a tile is just a sprite, basically a sprite. But instead of having to store a big background or picture like we see over here, like no, this is not the right image. Where is it? Title screen. Set tile intro background. I don't think she has a so this is the map 1 and 1, and we have a tile picture down here. No, this maybe this specific. Okay, I'll look for it again. It was in the wrong place. So so you can see, do you see the picture here? I'll open the game. Game for you. Many below. So do you see the background of the game? So one you right now our current example has only you know, just a very sad background, right? So what we have here is not like this, oops, but like this, just like that, right? So they're completely boring compared to this, right? So I want you to draw the background using a single image, right? But instead break it down into tile, right? And we have the tile map over here, which means the tile or the sprite to compose the whole background. Like I say, I saw it over here for you. Here is the tile, right? So you don't have a big picture, right? But you split the whole screen into tile. So how to do that? So you have the background of the scene, right? Of each world. So you use the two software to do that. So the first software is Shoebox and Tile Edit, so that you can come up with how to draw it. But I don't think you really want to use those at this stage, because I just want to do it simple. So because we don't have to create a the whole world one background, just the first part of the world. So we just need this little area. So how to draw this little area without having to draw the whole big pictures? Okay, think about it. Am I clear right now? Am I clear? Hello?
Sir,
Do you guys get it? Yes? Okay. So draw the crowd for me, but place onto the screen. So try to break it down into little sprite, right? Okay, so that is the assignment for the second assignment I want you to do. So you need to submit your code onto your repo, and when you are done, so you just send me the any work. So you say I'm done, sir. So I can go to your repo and look at that. So basically, send me a link to your repo, right? When you're submitting the assignment, right? I will go over your repo and see if you are doing it correctly. Okay. Okay, so I will stop sharing the screen and see if anybody has finished the exercise.
Teacher, is this we have to pre-render this background, and when we play the game, we just load the background. Is that right?
Yeah, what do you mean by pre-render?
I mean, it's we make a completely image.
No, we don't build up the whole image, right? So the whole point of a tile background is not to big image. For example, if we look at the picture your friend is sending, right? So we don't store the whole image like this, right? But instead, because the whole image is very big in a very early console, so we don't have that much memory or space to store a big image, or even enough memory to process such a big image, right? So we have to break it down into little part, right? For example, the whole area down here. So instead of having to store a big picture, so you can store the image of just one little brick, and you can draw it many times, so that you can create a whole line of bricks. Great. So for the cloud here, so you don't have to store the whole of the. Oh, looks like I'm not sharing my screen. Okay, sorry.
So basically,
again.
we store the position of the object.
Sort of, not really the object, because the background is not an object, but you can think of it as a sprite only. So so for example, you want to render the brick here, right? But it is not an object because we don't interact with the background object or the mountain down here, right? So you just render two sprite over here, remember, and to create the whole background. And what about the little sky here? We don't need a big picture of the sky, right? So we just need one little tile of the blue sky, or even the cloud here. We don't need a big picture. We just need 2 or 3 sprites to render it little over there, something like that. Get me a background, okay? But don't render the whole big image. Break it down.
Okay, thank you.
Are we done with the exercise, putting Goomba into the example? Can somebody show me before we finish today?
I think I managed to do the task.
Sure, great. Can you share your screen?
Okay. Did you see the screen? No. Did you see the screen? Did you?
I do.
Okay. So I don't flip it. I just got. I don't know how to flip, but I think this is enough.
Okay, I think it's enough. Well, actually, Goomba does not have left and right animation because it is the same, right? If moving left or right, it's just the same. So,
Yes.
good. Can you show Can you show the code?
Okay.
Yeah.
In the Mario.h, I just copy the code of Mario and replace some character.
Mm-hmm.
Just like that in the render, in the CPP.
Okay, go over that, please. I want the other to see as well.
Okay, yeah, it's right here.
No, I mean the render function body.
This is the render function is here. Because I
For
see
Goomba, I don't see. I only see the header. Can you go over the render function of C Goomba?
Because I saw that the brick, the code of the brick is stored in Mario.h. So I
Oh yeah. So you go over Mario.cpp.
yes.
Go over Mario.cpp so that I can see how you implement C Goomba.
In CMB, I just replace the ID which I create a random in the main function.
Okay.
I have these two ID. Yeah, it's right here.
I don't think anything on your screen. Can you share the screen again? Looks like it's stuck.
Okay, I will say it again. Do you see it now?
Yeah, see it here. So you are at the main.cpp. So you add an animation, right?
Yes.
So the animation ID is what? Is 521, 21 and 22, right?
Yeah.
Oh, 20 and 21. Okay. And you create Goomba. Okay. So can you go over the implementation of Goomba?
It's right here.
For some reason it's stuck. Your screen stuck. Can you share again? Stop and share again.
Okay. I think it's the network. Do you see it now?
Yep, I see it there.
Yeah, it's just 5 lines of code.
Okay, I think that's enough. So you know how to use the sort of a little framework, animation framework here. Okay, and I think it is enough for you to do all sort of animation in the game. Okay, we will stop here. Anybody has anything else to say or to ask before we stop? And don't forget to do the assignment, okay?
Okay.
Background. Show me the background, but using the tile, not the whole picture. Okay, so nobody asked anything, so let's call it a day then. What is it? Okay, have a good weekend, guys. See you next week.
Okay, see you next week too, teacher.
Bye, teacher.
Goodbye.
Bye.